learn the nomenclature. Like for example, we have this part. Let's suppose we have CH3, C, C. This is the main carbon chain. And we have a double bond here and we have a double bond here. Right? And that's how the structure is. And I am supposed to name this compound. Okay? Now, how do you think I'm supposed to name this compound? Just have a look. So, this compound has how many carbons into it? It has carbon 1, 2, 3, 4, and 5. Yes or no? Right? So,
Yeah.
5 carbons would mean the word root shall be pent. The word root shall be pent. And there are two enes right here. One ene double bond and one ene double bond. Yes or no? Yes or no?
Yeah.
So, ene and ene. So when one similar thing is repeated several times, it means it is twice in. So it shall be what? It shall be diene. Are you understanding? It shall be a diene. And at what positions is the double bond starting? The double bond is starting at position number 1 and ending at position 2. And in this chain, the second double bond is starting at position number 3 and ending at position number 4. Yes or no?
Yeah.
So I will write down pent 1, comma 3. The starting numbers I will be mentioning. The starting numbers I will be mentioning 1 and 3. So I will have pent. And now the name here becomes penta. Penta 1, comma 3 diene. Are you understanding my point? Penta 1, comma 3 diene. Are you understanding my point?
Yeah.
Right? So now if I give you this kind of structure, so if I have one, two, three, four, five, six. So basically, when een and ein, they are repeated several times, like more than once, then what do we say? We say that, it is pentadiene. Are you understanding my point?
In the second one, why is it HC instead of CH?
It could be CH, it could be HC, doesn't really matter. You can connect it here. So basically, I have to show a carbon carbon bond. So I can write this down as HC single bond CH. I can do that too. That's fine. And here also, the correct way is to write down H3C. So as to, not miss any carbon carbon bond. Are you understanding?
Yeah.
Yes or no? All right. Okay. So now if I draw this particular structure, so I have this double bond right here, double bond here, and okay, and a triple bond right here. Okay. And it is CH3, CH2, CH2, CH, and I will have CH, and I will have CH. So what do you think we have it right here? One, two, three, four, five, and six. Six carbons we have. So the word root shall be hex. But because I can see a triple bond and I can see a double bond, the compound shall actually show me the properties of a triple bond. So the name shall be ein and the name shall be een. So the one whose properties are actually depicted, that suffix ayush is shown exactly at the end. You understand? So when that is shown exactly
Yeah.
at the end, so that shall be hex, een, and ein. So it shall become hex, one een. Okay, hex een. Now the number is to be written down. So now who is getting the preference? Who is getting the preference? The ein is getting the preference, right? Who is getting the preference? The ein. Preference as in like its properties are actually being shown. So basically one, two, three, four, five, six. Yes or no? So ein, I will
Yeah.
write it down as hex one ein, and whichever number shows the preference, that number comes first in the class. You understand? So that number is given the least preference, most preference, and it gets the least number. So you have hex one ein and three ein. Are you understanding my point? So that shall become hex three ein
In
one ein.
En is written before the wine, then that one because of alphabetical order, right?
No, no, because ions properties are shown maximum in the compound. Ions property are shown maximum in the complex, in the compound. You understand my point?
Yeah.
Okay. So this is how we name the compound. So we will have hex 3 ene and 1 ine. Yes or no? All right.
Yeah.
And what do we do in here? What do we do in here? We break this particular bond. So we will say when we write down ene. So there are two suffixes now. Ene is suffix 1 and ine is suffix 2. So whenever we are writing two suffixes, one suffix, the first suffix that you're writing down should not end with e. So you have to drop this e. So the name shall become hex 3 in 1 ein. That's how the name has to be written down. So when you have two suffixes written just one after the other, okay? When you have two suffixes written just one after the other, I hope you're understanding that in and ein, you know, you have to drop this e for the suffix number 1 and the name shall be written down like this. So hex 3 in 1 ein. Are you understanding my point?
Yeah.
Okay, so this is how you name the compounds. So for example, if I give you this particular structure, if I give you C, this name structure, and I have a triple bond, and I have a triple bond, and I have a double bond, and you complete the hydrogens. So you complete the hydrogens like this. So how many carbons do you think we have? Carbon 1, 2, 3, 4, 5, 6, 7. So word root shall be hept. And we are able to see what? We are able to see a hepta. Why a hepta? Because the triple bond is there. A triple bond is there, and the triple bond is actually seen two times. So when the triple bond is actually seen two times, I hope you're understanding that it shall be hepta. And hepta, then I am seeing ine, but there is a triple bond in the structure and there is a double bond also. And the double bonds property are actually not shown so much. They become sort of, they get repressed. And the properties of triple bond are more dominant. They are shown in the compound more. So then I would say ine is happening two times. So I would say diine. I would say diine. Yes or no? And there is a ene as well. And when there is a ene and ine, I have to tell me the positions also. So diine, ine 1 starts at carbon 1, ends at carbon 2. So 1 comma 3. Yes or no? It starts at
So
1 comma 3.
the one with the most preference will be at the end.
Exactly. So I have to show
Okay.
the nature of the compound. And ene is basically starting at 5 and ending at 6. And the rule is that, when we have two suffixes, suffix 1 and suffix 2. So we have ene and another could be a, e, I, o, u, y. So if the second suffix starts with a, e, I, o, u, y and the first suffix ends with e, okay, the ending of first suffix if is with e, you understand, and the second suffix starts with a, e, I, o, u, y, then you drop this e, drop the ending e, you understand, of suffix 1. So but here it is
Yeah.
starting with d, so I cannot drop this e. So here I will not be dropping this first suffix e. Do you understand the rule? So the name shall be hepta
Yeah.
5 in 1 3 di I. Are you understanding? And you write down the
Yeah.
numbers
Understood.
here. You write down the numbers here for the starting, the starting carbon for that particular triple bond or for that particular double bond. Like for example, here the triple bond is starting at 1 and ending at 2. and the triple bond is starting at 3 and ending at 4. Are you understanding? So
Yeah.
that's how we sort of name the complexes. Now, when I have this particular main chain, so basically the finding of the main chain is important. Then you can come up to the side chains. Now, the side chain could be a alkyl group. Yes or no? The side chain could be an alkyl group like this, like this. So what do you have in here? You count the carbons 1, 2, 3, 4, and 5. So word root is pent. So word root, and everywhere in the chain there is a carbon carbon single bond, carbon carbon single bond, carbon carbon single bond, carbon carbon single bond. So everywhere the word root is pentane. So everywhere it is there. So I cannot say pent 1, 2, 3, 4, 5, 6. So I will simply write pentane. So I have counted the longest chain. Okay. The first rule is to count the longest chain. The first rule is to count the longest chain. Are you understanding? And when we have counted the longest chain, so we have 1, 2, 3, 4, and 5. You understand? And after that, what is left outside? CH3 and CH3. So whatever is left outside is a alkyl group. So this carbon is only one carbon, so you will name it as methyl. This is methyl alkyl group. And methyl shall become dimethyl. Are you understanding? Right? So it shall become
Yeah.
dimethyl. So dimethyl. So it shall become 2 comma 3 dimethyl pentane. That's the name. So the rule is count the longest chain. And secondly, what do we have in here? The side chains. The side chains. If in the side chains any carbon is left, so that shall always form an alkyl group. The side chains always form an alkyl group. The side chains always form an alkyl group. And the alkyl groups are always prefixed. The alkyl groups are always prefixed. Are you understanding my point? Okay.
Yeah.
So we have 2 comma 3 dimethyl pentane, and alkyl groups are always prefixed. Are you understanding my point? So methyl group is actually repeating itself 2 times, hence the di. One carbon is left on the outside of the main chain. This is the longest chain. So when one carbon is left on the outside of that carbon chain, so that is methyl. So it shall be 2 comma 3 dimethyl pentane. Are you understanding my point?
Yeah.
You understand? So that's how the name should be. That's how the name should be. All right. So for example, if I have this particular structure, so if I give you this chain, the carbon chain, and now you have to, tell me which chain would be the longest chain, like this. What do you think we have in here? We have 1, 2, 3, 4, 5, 6. So you can't simply go straight. Okay, you have to think on it. Like for example, you started carbon 1, 2, 3. Now when you look at carbon 3, right? You have two ways of choosing. Either you can go to yellow line or you could go to green line, isn't it? You started with the blue line. The moment you reach carbon number 3, you understand? The moment you reach, you have two paths to choose from actually. So first path can be either you can move from 1, 2, 3, and 4 and 5, or it could be 1, 2, 3, 4 and 5, or it could be 1, 2, 3, like 4 and 5, both in red, or it could be 1, 2, 3, 4, 5, 6, the blue numbering, or it could be 1, 2, 3, you prefer to move forward 5 and 6. So how many chains could you see? This is one chain, Ayush. This is second chain, the blue chain straight away. And there could be another third chain, which could be this. Yes or no? So it could be one, two, three,
Yeah.
four, five, six. It could be one, two, three, four, five, six. It could be one, two, three, four, five. You understand?
Yeah.
So three chains to choose from. So first of all, this red chain I'm going to discard. Why am I going to discard the red chain? Reason is that
It's the small one.
it is a small chain. So this is not required. Now from the green chain and from the blue chain, you can choose any of the chains because they're exactly the uh you know of the same length. They contain same number of carbons. Also, you choose that chain. So sometimes it happens that we have two chains of the same length. So sometimes there is a choice also to make between them. You can't straight away choose any of them. You have to choose that. We have to choose that main chain which has maximum number of side chains into it, which has maximum number of side chains into it. You understand?
Yeah.
Okay. So that is the concept. So for example, when you have one, two, three, four, five, six, if I choose the blue chain, I have two side chains out of it. And if I go one, two, three, four, five, six, if I choose a green chain, then I also have two side chains out of it. So then I can do any chain. So I'll prefer the straight chain. I hope you're understanding the method of how I think, you know, to which chain am I supposed to count into as a main chain.
So in this case, we can pick blue or green. Yeah.
Exactly. Yeah,
Okay.
they're both equally, you can choose in any one of them. Equally capable of being counted as a main chain. So this would be my main chain. And now I am left with two groups outside. So we'll name them later on because whatever is left outside and has carbon into it, you understand? So I would have hexane because the main chain has six carbons. Word root for six carbons is hex. Everywhere there is a single bond. So it is a hexane. Yes or no? Right?
Yeah.
And now what do we have in here? We have one carbon group outside. So one carbon group is called methyl. And here we have a two carbon group. A two carbon group. You understand?
It that. Yeah.
Ethyl. So you call it as ethyl. And you have to count these carbons. So from one third carbon, these two are counted in detail. So this is how it is connected. I hope you're understanding. CH2, CH3. Understood. So we will
Yeah.
have hexane and methyl and ethyl. Now it's like the two side chains. Now ethyl comes E alphabetically first. So I'll write down ethyl first and later on methyl. Then the numbers, ethyl comes at carbon number 3. So now the choice is to how to number it. So 1, 2, 3, 4, 5, 6. Now, according to the red numbering, methyl comes at 2 plus ethyl comes at 4. So 2 plus 4 is 6. And according to the blue numbering, ethyl comes at 3 and methyl comes at number 5. So the sum is 8. So I have to number the chain in such a way so that the sum of the numbers is the least. So I will prefer the red numbering. I will prefer to number it from left to right. Understood or not?
Yeah.
All right.
Yeah.
So my answer shall be 1, 2, 3, 4, 5, 6. So how do I put it here? So 4 ethyl and 2 methyl. That's the name of the concept of the compound. Understood or not?
Yeah. Understood.
So this is also called as a lowest locant rule. Lowest locant rule. You understand the point,
Yeah.
right? So this is the concept. This is the concept. So similarly, if I give you this compound now, just see, right? Now just understand how am I supposed to name the structure, Ayush. So now here you can see that longest chain is this, right? But the preferable compound
Yeah.
is, the preferable bond is C double bond C. You understand? The preferable bond is C double bond C. Why is
Yeah.
that so? Why is that so? Understand? Because the compound, we already know the preference order that, in a chain, if there is triple bond, that property would be shown more, then double bond, and then single bond. What is happening here? So here we have double bond. So for second rule is that, sometimes it is possible that with this numbering 1, 2, 3, 4, and 5, this red chain is smaller chain. This red chain is a smaller chain. What would that mean? Being a smaller chain, even it is a smaller chain, but it consists of the main important bonds. So I will consider this 5 carbon chain as my main chain. You understand? Because it contains both the
Yeah.
double bonds. Are you understanding?
Yeah.
So that is why the main chain here shall be pent. And now this main chain is not consisting of only 5 bonds. It is consisting of what? 1, 2, 3, 4, 5. It is consisting of penta. It is consisting of penta. And why penta? Because there is a double bond, two double bonds right here. So we have
Double.
pentadiene.
Yeah.
Pentadiene. And what is pentadiene? 1, comma 4. Penta 1, comma 4 diene. And one group is left outside now. Okay, so why am I not numbering? I can try numbering it from the other way around also. 1, 2, 3, 4, 5. So if I look at from the other side also, it would still be 1, comma 4. You understand? You understand? So which numbering is still better? The blue numbering is better. Now tell me why. Because when I number it from the according to the blue numbering right here, like this, you know, if I number it according to the blue numbering, you see that this particular main chain, sorry, right? So this particular blue chain is numbered like this. So I hope you're understanding that the second carbon, this group is connected. And this shall be ethyl. So ethyl, because numbering, if you number it from 1, 2, 3, 4, 5, left to right, or bottom to up like this, both the numberings are correct. You know, 1, 2, 3, 4, 5. There is no change in the naming of diene. Diene shall remain diene. Are you understanding?
Or ethyl will get smaller
The
number.
ethyl will get smaller number, and that's the preference. So that is why we will say I would number it from the according to the blue numbering. That is better. So it shall be 2 ethyl penta 1, comma 4 diene. Understood or not? So 2 ethyl
Yeah.
1, comma penta 1, comma 4 diene. Understood or not? Yes or no?
Yeah.
Right. So that is how you are supposed to name it. So the rule is that not always the longest chain is the main chain. The main chain is the one case is it should be longest. If it is not the longest, it should consist of all the important bonds into it. All the double triple bonds should be accommodated into that main chain. That's how it should be actually named. Are you understanding? All right.
Yeah.
Now, for example, we have another structure for that matter. So we have this thing. So yeah, that's all the rules all about. So we have this particular structure now. So here, if we have this and the triple bond is here, you understand? Now, this is a new rule for you. CH3, CH3, CH, H, H2. So, how many carbons do you think we have? We have 1, 2, 3, 4, 5, 6, 7. 7 carbons we have. So, the word root shall be hept. And definitely, ine is the main functional group here. So that will come at the end. Then comes the "een." As much as I know, I'm just trying to accommodate into the name, right? I'm going to drop E because I know there is suffix 1, there is suffix 2, and suffix 1 is there and suffix 2 is there. I'm going to drop this E. You understand my point? And
Yeah.
that's the name. But the point is, you see, if I number the chain from both the sides according to the blue numbering and according to the red numbering, just have a look at the blue numbering. The een, is coming at number 2 from left to right numbering. From left to right numbering, the "een" is coming from at number 2. And from right to left numbering, red numbering, the "ein" is also coming at number 2. Just have a look. Yes or
Yeah.
no? That means what? That it is a symmetrical
That.
structure. This is called as a symmetrical structure. This is called as a symmetrical structure. Are you understanding?
Yeah.
And when you have, when you see the numbering from both the sides and you see, okay, the double and the triple bonds from both the sides, they are exactly at the starting at the same carbon, symmetrical structure. Then for sure you understand that the properties definitely triple bond will show. The properties are dominant definitely for the triple bond. You understand? But for the double bond,
Yeah.
so triple bonds property definitely are, more dominant. But for the double bond, the double bond's number should be the least. You understand? Normally, what we were doing, the preference was given to triple bond in every sense. The properties would also be shown to triple bond, and the triple bond would get the least number. But in the symmetrical structures, what are we doing? The properties are definitely shown by the triple bond, hence the suffix "ein" at the end. But during numbering, the double bond gets the least number. You understand? The double bond gets the least number.
Instead of double, if it were, wait, will it always be the smaller bond that gets the least number?
No. If it would have been a different structure like this, double here, triple here, is it a symmetrical structure? You tell me. It is not a symmetrical structure.
No.
So let's suppose double bond was here and triple bond was here, let's suppose. Here. So I would number the chain from here because then, it is not symmetrical. So in every sense, the triple bond will be preferred. The triple bond will have "ein" and the smallest number as well in the end. You
Yeah.
understand? That shall be the name. But when there is
Double
a
bond, I mean, yeah. So symmetrical structures when both the bonds get the same number in both the directions,
yeah,
the
that's
numbering, right?
symmetrical. And in that
Okay.
symmetrical structure, the double bond, though, is not preferred in terms of the property, it does not is shown in terms of the property, but it is actually shown with respect to the number you get. You preferably give the
Yeah.
double bond the first position in the class, the smallest number in the class. You say, okay, you get more importance. Just the way of understanding that it is a symmetrical alkene. You understand? Symmetrical structure consisting of both double and triple bonds.
Yeah.
So that's how it would be. So when you say hept and it is symmetrical, the properties are depicted by "ein." But the "een" gets the smaller number, so my blue numbering is preferred. You understand? My blue numbering is preferred. And it shall be hex 2 "een, 5 "ein." Understood or not?
Yeah.
Yes or no? But here you see, here "een" gets a bigger number. So from the bigger number itself, I can make out that it is not preferable. it is not a preferable functional group, it is not a preferable suffix. That means "een" is not getting preference. So who is coming, who is getting a better position in the class? "Ein" and then "een." You understand my point?
Yeah.
So this is
Yeah.
the symmetrical structure, and the double bond gets the least number. But the properties, write it down, but the properties are depicted still by, but the properties are more depicted still by the triple bond. So in terms of properties, this shows the least max learned up till now. That naming, that naming. So for example, the naming of the functional groups. Naming of functional groups. All right. So when we are talking about the naming of the functional groups, so how do we name the functional groups? So we have four functional groups with us. We have four functional groups with us. What are those functional groups? Primarily, we have alcohol. So you get to see the function OH, structure OH into it. You have aldehydes. So you get to see CHO. You have the ketones. So you get to see the C double bond O group and R dash. And what is CHO? R C double bond ONH. And last, you get to see the carboxylic acid. There are, 40 functional groups. But the carboxylic acid that you get to see here is R C double bond O OH. You understand? Right. So these are four functional groups and their suffixes would be. So now whenever a functional group is present in a structure, then double bond, triple bond doesn't matter. Now the properties of the functional group will dominate. You understand? The properties of the
Yeah.
functional group will now dominate. So now every functional group has its own suffix. And when every functional group has its own suffix, what does that mean? You tell me. What does that mean? So OH, the suffix of OH shall be ol. The suffix for aldehyde shall be al. The suffix for ketone shall be on. And the suffix for this shall be oic acid. You understand? The suffix shall be
Yeah.
oic acid. Are you understanding my point? So when we are talking about the alcohol, aldehydes, ketones, and carboxylic acid, that's oic acid. Understood or not?
Yeah.
So when we are talking
Understood.
about the naming of the functional group, you understand that alcohol is OH, CHO is aldehyde, ketones, carboxylic acid. So they have their own suffixes, and now you know that the functional group gets more preference every time. So what is the order now? The functional group followed by a triple bond, followed by a double bond, and then followed by a single bond. And what is this preference order? The preference of the domination of the properties, that whose property would be depicted more in a compound. So preference of the dominance of properties. And whosoever's properties are being depicted, whosoever's properties would be depicted will have the maximum, will have the last suffix. So if I have several suffixes, suffix 1, suffix 2, suffix 3, so the last suffix shall be the main suffix, that actually is the compound. So if the last suffix is oic acid, it doesn't matter what else it has. They would all be secondary, and this would be my main suffix. Are you understanding my point? Yes or no? Okay,
Can you explain again?
I'll just tell you. So for example, I give you this structure. I have one, two, three, four. So there's a triple bond here, there's a double bond here, and there is an OH here. And this is the structure. You understand? This is the structure.
Yeah.
So we have one, two, three, four, and this. So the main functional group here is one, two, three, four, five. So word root is spent. I can see
Yeah.
an een. I can see an ine, and I can see an ol as well. Ol is what for the functional group?
Mm.
Why
Yeah.
have I numbered here like this? Why am I giving numbering from left
Mm.
to right? Tell me, or from
Because
right
it
to left?
all
Because, yes,
because the functional group will have preference.
exactly. So the second carbon will have OH. You understand?
Yeah.
One
Yeah.
second.